Welcome to interpreting the correlation coefficient in context. So the idea here is essentially we want to be able to use the correlation coefficient to describe what that means for the relationship between the variables we are working with. So we want to use the correlation coefficient to tell us about the relationship between the variables being studied. So for interpreting positive correlation, again, positive correlation, what this means is our graph looks to have a general trend that the dots are going up. So if we think of this as variable 1 and variable 2, and we have the low values and high values, and low values and high values, then essentially what we have here is high values of variable 1 tend to be paired with high values of variable 2, and low values of variable 1 tend to be paired with low values of variable 2. So we can describe this as higher values of variable 1 tend to be paired with higher values of variable 2. We will see an example of this with specific variables towards the end of this video. Interpreting negative correlation, we are looking at the opposite. So for negative correlation, we have our variable 1 and variable 2. On the number line, we have our low values and high, low, and high. And this time the dots go down. So if we do the same thing as we did last time, this time around high values of variable 1 are matched with low values of variable 2. And reversing that, low values of variable 1 are matched with high values of variable 2. So for a negative correlation, the variables go opposite of each other. So higher values of variable 1 tend to be paired with lower values of variable 2. Then we have interpreting the strength of the correlation. So what this means in terms of the relationship If we have a strong correlation, then this means that the pattern is fairly consistent. If we have a moderate correlation, then the pattern is somewhat consistent. And if we have a weak correlation, then the pattern is inconsistent. So let's go with fairly inconsistent. We sometimes also have something we refer to as a null correlation. This is basically when it's so weak that the pattern is essentially not visible at all. So R is essentially 0. Then there is no relationship, no observed relationship. So if we continue on, we're going to take a look at a couple examples. So as we read through these problems, some things to take note of: what our two variables are, and then what information we are told. So in this example, a study was done on the relationship between height in inches and weight in pounds of adults. A linear relationship was found. So this is good. In our correlation, we're specifically focusing on linear relationships. And our correlation coefficient was R equals 0.78. So our job is to figure out what this means. So just looking at the correlation coefficient, R equals 0.78. This is positive. And 0.78 we classified as strong. Right? It's between 0.7 and 1. So we have a positive, strong linear relationship between height and weight of adults. So that's one sentence we can write. So this sentence is our statistics vocabulary sentence. Is sort of our first option. We can say there is a strong, positive, linear correlation between height and weight of adults. If we want our non-statistics vocabulary version, so this is essentially what would make sense to the general public. So for the general public, interpreting the positive, what we can say is, so positive, we have high variable 1 is paired with high variable 2. So high heights or taller people, taller adults, tend to be or tend to have a higher variable 2, so tend to have a larger weight or tend to weigh more. So taller adults tend to weigh more. So that's high variable 1 paired with high variable 2. And then strong means that the pattern is fairly consistent. So this doesn't mean that a taller person necessarily weighs more than a shorter person, but this is just a general observed pattern that taller people do tend to weigh more. Again, key word here is that tend. So there's a observed pattern, but it's not guaranteed. Next up, we have I don't have a capital A. A study was run on the relationship between annual income and commute time to work. The relationship was found to be linear with a correlation coefficient of R equals negative 0.62. And we want to know what this means. So again, we're looking at annual income versus commute time to work. I didn't specify the population in this study. We have a linear relationship and a correlation coefficient of R equals negative 0.62. So R equals negative 0.62. We have a negative correlation. And then this is moderate. Again, our R is between 0.5 and 0.7 if we ignore the sign. So using statistics vocabulary, what this tells us is that there is a moderate, negative, linear correlation between annual income and commute time to work. Again, this doesn't mean much to the general public, so let's do a version for the general public. So we have a negative correlation. This is high values of variable 1. So people who tend to have a larger annual income, people who make more, are paired with low values of variable 2. So they have a shorter commute to work. So people with a higher annual income there's our higher values of variable 1, tend to have a shorter commute time to work. Again, we have a moderate relationship. This means that the pattern is somewhat consistent. So this pattern is somewhat consistent. Again, it's not perfect. It's less consistent than the previous problem we were working on, but the pattern is still observed. So this is interpreting the correlation coefficient in context.